A blessed day, everyone. Welcome once again to our new lesson. Today, we're going to discuss about the CPU scheduling. Let us have the classification of CPU scheduling. CPU scheduling may be classified as non-preemptive scheduling. CPU scheduling is non-preemptive if once the CPU has been assigned to a process and the process starts executing, the CPU cannot be taken away from that process. The next one is preemptive scheduling. In preemptive CPU scheduling, even though the CPU has been assigned to a process and the process is already executing, the CPU scheduler may decide to assign the CPU to another process in the ready queue. Performance criteria of a good scheduler. A good scheduler should optimize the following performance criteria. We have CPU utilization, throughput, turnaround time, response time, and waiting time. There are different CPU scheduling algorithms. First is the first come, first serve algorithm. The second one is the shortest process first algorithm. The third one is the shortest remaining time first algorithm. The fourth is the round robin algorithm. The fifth is priority scheduling. And the last is the multi-level feedback queues. Let us have first come first served algorithm, or the FCFS. Here, the rules is the one that enters the ready queue first gets to execute at the CPU first. So let us have our FCFS table. So we have here process ID A, B, C, D, and E. So we have 5 processes, and their arrival time is A arrives 0 milliseconds, B is 3 milliseconds, C is 4 milliseconds, D is 6 milliseconds, E is 10 milliseconds. And their CPU burst, A is 8, for B is 4, for C is 5, for D is 3, and for E is 2. So let us continue to solve the schedule. So let us have or accommodate process ID A, or process A. So here, we're going to accommodate or schedule process A, and we're going to put it here, the process A, and we're going to consider its arrival time at 0 millisecond, and we're going to put here 0 millisecond, and we're going to place its burst time of 8. So we're going to place it here, and the CPU will process A for its burst time of 8. So next, let us accommodate process B here. So since we're done with letter A, the CPU can now accommodate to schedule process B. And from the time the CPU finished letter A is 8 milliseconds, it will accommodate the arrival time of letter B, which is 3, and it will add the CPU burst here. Okay, so from the CPU burst of 8 and now 4, so 8 here plus 4 will give us 12. Okay, then now process A and B are now scheduled to our ready queue. Next, we have now the arrival of process C at 4 milliseconds. Okay, so we are done putting the schedule of process A and B, and C now will be accommodated here. And we're going to add its process burst of 5. So the finished process for process A and B is 12 and will be added by 5. So 12 plus 5 is 17. So the processing time right now for process A, B, and C is 17 milliseconds. So next, we will accommodate the process letter D. So let us use again the table, and let us continue for the fourth process, or the process D. And let's continue placing letter D here. So we stop with the finished value of 17, and letter D here has the CPU burst of 3. So 17 plus 3 will give us 20. And now the processing time for all the processes is 20 milliseconds. So let us now continue to process the last process E. Okay, so let us place process E in our last queue. So we stop with the value of 20 milliseconds, and let us look at the value of CPU burst of process E, which is 2. So 2 plus 20 here will give us 22. So now we are done processing all the processes of here, letter A, B, C, D, and E. Okay, so let us go to our computation. We are now going to compute for the average waiting time of letter A. Okay, so first we're going to compute for the average or the waiting time for letter A. So here we're going to look at the tail part of the letter A, which is here. This is letter A, and the tail part is 0. So we're going to put 0 here. And we're going to look at the arrival time of letter A. Letter A, arrival time is 0, and we're going to put it here. So we're going to subtract now the values. 0 minus 0 will give us 0 milliseconds. So the waiting time for letter A is 0 millisecond. So let us go to the waiting time of letter B. So let us look at the tail of letter B. Here is the tail, and the value is letter 8 or 8, and we place it here, 8, and we look at the process B and its arrival time, which is 3, and we're going to place it here, 3, and we're going to start subtracting the values of 8 minus 3 will give us 5 milliseconds, and the value of, or the waiting time for letter B, process B, is 5 milliseconds. So let us solve for the waiting time of letter C and look at the tail of letter C. Here is the tail of letter C, and the value of the tail of letter C is 12, and we place it here, 12, and we look at the arrival time of letter C. The arrival time is 4, and we place 4 here, and we subtract the values. 12 minus 4 will give us 8 milliseconds, and the value or the waiting time for process C is 8 milliseconds. Let's continue with the waiting time of process D, and let us look at the tail of letter D in our graph, and let us get the value of 17, the tail of letter D, and place it here, and look at the letter D arrival time, which is 6, and place it here, then subtract 17 minus 6 will give us 11 milliseconds. Okay, so the value of process D waiting time is 11 milliseconds. And let's go to the last waiting time of process E. So let us look at the tail of letter E, process E, which has the value of 20, and place it here, and let us look at the process E here and its arrival time, which is 10, and place it here, and we can now subtract 20 minus 10 will give us 10 milliseconds, and the value of process E for its waiting time is 10 milliseconds. Now we're going to get all the result of subtraction, and we're going to put it here. So 0, we're going to get here 0, and we're going to place it here for letter A, and 5 for B, and 8 for letter C, and 11 for letter D, and 10 for letter E. And we divide it by 5 because we have here 5 processes. So like 1, 2, 3, 4, 5. The reason why we divide it by 5. So adding this values here will give us 34, and divided by 5 will give us the result of 6.8 milliseconds. So the average waiting time for all these processes is 6.8 milliseconds. Okay, so let's move to our next. Here we have we're going to compute the turnaround time of process A to process E. Okay, by looking at again our Gantt chart here, Gantt chart and our table, we can solve for the turnaround time of each process. So let's start with turnaround time of letter A. So here we're going to get the head part of our process A. So here the head part of process A is here, and the value of A is 8. We're going to place it here, 8. And we're going to go to the process table of process A, and we're going to get the arrival time of 0 and place it here. So 8 minus 0 will give us 8 milliseconds, and the result for the total arrival time or the turnaround time for letter A is 8 ms. Okay, so next, solve for the turnaround time of process B, and we're going to look at the head part of process B here in our Gantt chart, and the value is 12, and we're going to place it here. And we're going to look at process table in our process table and look at the arrival time of process B, which is 3, and place it here and subtract. 12 minus 3 will give us 9 milliseconds, and the turnaround time of process B is 9 milliseconds. So next is the turnaround time of process C, and we're going to look at the head part of letter C, which is 17, and place it here, 17. And we're going to look at the table of process C, and we're going to get the arrival time of 4 and place it here. Now subtract the values, which is 17 minus 4 is equal to 13 milliseconds, and the turnaround time for process C here is 13 ms. So next, we solve for the turnaround time of letter D and look for that head part of letter D in our Gantt chart, and the value is 20. Place it here and look at the table of process D and get the arrival time of process D, which is 6, and place it here. Then subtract 20 minus 6 is 14 milliseconds, and the turnaround time for process D is 14 milliseconds. Okay, we're going to move to our last process for the turnaround time of letter E or the process E. So we're going to look at the Gantt chart again and the head part of our process E, which is this one, and the value is 22, and place it here, 22, and look at our table for the process E and get the arrival time of process E, which is 10, and place it here, and subtract will give us 12 milliseconds. So the turnaround time of letter E or the process E is 12 milliseconds. Now we're going to compute the average turnaround time for the solved values. So we are going to get 8 for our process A, 9 for our process B, 13 for C, 14 for process D, 12 for process E, and divide it by 5. So we divide it by 5 because we have here 5 processes in our table. And adding all the values here will give us 56. Divide 5 will give us the result of 11.2 milliseconds. So the total turnaround or the average turnaround time for these 5 processes is 11.2 milliseconds. Okay, so that's how you're going to compute for the FCFS turnaround time or the average turnaround time. So next, we move to our next algorithm, which is the shortest process first algorithm, or SPF. Here, the rules is the process with the shortest CPU burst will be considered. Okay, so let us check the table. So we're going to use the same table, and we're going to start plotting our Gantt chart here. So let us consider first the process A here and place it here. We're going to get the arrival time of 0 for process A. So place it here, 0. And its CPU burst of 8 and place it here. So the CPU can now process the scheduled letter A for the process letter A. Now, another process will arrive, which is process B, and it will be scheduled again to our queue, CPU queue. And we will have here, we are done with letter A, which is 8. And since here we already processed 8 milliseconds, so here is our arrival time. So we're going to check the time for the process or the finished time. It should be within this 8 ms or 8 milliseconds. So the CPU can now check up to here for the CPU burst. Okay, and the CPU can now accommodate the shortest process here, or schedule the shortest process. So now, by looking at this CPU burst here, the shortest process is 3, which is process ID of D. Okay, so now the CPU will schedule process D here. The reason why after A, letter D is now being scheduled by our scheduler. Okay, then we're going to get the value or the CPU burst of 3 here, and we're going to add to 8. So 8 plus 3 will give us 11. Okay, so the CPU has now processed 2 processes having 11 milliseconds. Now, the total process time is now 11. So from 0, it will continue up to 11 ms. So it already sees the value here for the arrival of 10 or the arrival of process D, and the CPU can now detect the CPU burst of letter E, which is 2. Now, this will be the new scheduling for the CPU, looking for the shortest process first. So after 3 here, the shortest process comparing all the CPU burst is 2 as compared to 5, 4. Okay, so now the CPU scheduler will accommodate 2, which is process E. And letter E, or the process E, will now placed in our Gantt chart for scheduling. And 2, the value of CPU burst for letter E or process E will now be added. So 11 plus 2 here will give us 13. Okay, so we already processed 3 processes. So we need to process another 2 remaining processes. So let us continue. And let us place our table here as our guide and continue for the shortest process first algorithm, and go to our 4th process and get our Gantt chart. So we're done with letter E, which is 13, and as you can see, we're done here, process E. And looking back, we can now accommodate or schedule 4 because we already processed 8. We already processed 8 for process A. We already processed 3 for letter D. And the only remaining processes is 4 and 5, or B and C, and it will be compared here. So which is the shortest process? So the scheduler will choose 4 because 4 is lesser than 5. Okay, so 4, the process ID is B, and it will be placed in our Gantt chart, process B, and we will be added to 13. 13 plus 4 here, plus 4 will give us 17. Okay, so next here. So we're done with 17, and here is 17. And the last process that we're going to schedule is process C. Okay, and it has a CPU burst of 5, and it will be added here to 17 plus 5 will give us 22. Okay, so let us proceed with the computation here. So first, we're going to solve for the waiting time of each process. First, we solve for the waiting time of letter A. What is the waiting time for the process A? So again, our method is looking at the tail of letter A. So the tail of letter A is here, and the value is 0. And the next method is to look at the table, process A, and get the arrival time of 0 and place it here. And subtract 0 minus 0 will give us 0 milliseconds. And we go to the waiting time for letter B or the process B. Again, we look at the tail of letter B, which is in our Gantt chart is this one, tail of letter B, and the value is 13, and place it here. And look at the table for process B and get the arrival time of 3. So 13 minus 3 will give us 10 milliseconds. So next, solve for the waiting time of letter C or the process C. The same method, look at the tail of letter C, and here is the tail of our letter C or the process C. Get the value and place it here, which is 17. And look at our table for process C and get the arrival time of 4 and place it here. And subtract the values. 17 minus 4 is 13 milliseconds. Okay, we now go to the process D, the waiting time for the process D. So looking at the Gantt chart again, and the tail of letter D is here, and the value is 8, and place it here. And look at the table of process D and get the arrival time of 6 and place it here. Then subtract 8 minus 6 is 2 milliseconds. And go to the last waiting time, which is process E, and look at the Gantt chart for the tail of letter E, which is this one, and the value is 11. Here, place it here, and go to the table for the process E and get the arrival time and place it here and subtract. 11 minus 10 is 1 millisecond. Okay, then now we solve for each processes or the waiting time. We can now solve for the average waiting time for all the processes. Okay, so we're going to add 0 here plus 10 plus 13 plus 2 and plus 1. Okay, so adding those will give us 26, and we divide it by 5 here, 5, because we have again 5 total processes. So 1, 2, 3, 4, 5, 5 processes. So 26 divide 5 will give us 5.2 milliseconds for the average waiting time. Okay, so we can now solve for the turnaround time of this SPF. So let's continue. And let's place the table and Gantt chart. And we solve for each process for turnaround time. So the turnaround time of letter A is the same method that we did earlier. So we're going to look at the head part of our letter A. So the head part of letter A is this one, and the value is 8, and we place 8 here. And we look at the process A and look for the arrival time of 0 and place it here. Then subtract 8 minus 0 is 8 milliseconds. Next, solve for the turnaround time of process B. So let us use the same method looking at the head part of process B, which is this one, the head part of process B, and the value is 17. And look at the table for the process B and get the arrival time, which is 3, and place it here, and subtract 17 minus 3 will give us 14 milliseconds. So we continue for the turnaround time of process C. Look at the head part of letter C and get the value of 22, and go to our table for process C and get the arrival time of 4 and place it here, and subtract 22 minus 4 is 18 milliseconds. Okay, continue to solve for the turnaround time of process D and look for the head part of letter D or the process D, which is 11. Place it here and look for the table for the process D and get the arrival time of 6 and place it here, 6, and subtract 11 minus 6 is 5 milliseconds. And the last turnaround time for letter E or the process E, let us look for the head of letter E. The value is 13. Place it here and look for the process E in our table and get the arrival time of 10. Place it here and subtract, and 13 minus 10 is 3 milliseconds. Now we can now solve for the average turnaround time for all the processes in our table. So we add 8 here, 14, 18, 5, and 3. Okay, we're going to divide it again by 5 because we have here 5 processes. And adding all these values will give us 48. Divide 5 is 9.6 milliseconds. So 9.6 milliseconds is our average turnaround time for the shortest process first algorithm, or the SPF. Okay, so let's move to our next scheduling, which is the shortest remaining time first algorithm, or the SRTF. So SRTF is the preemptive version of SPF. So preemptive version, meaning it can detect or check the incoming processes. Unlike the SPF, it cannot. Okay, so let us check the process and the table here. So we're going to use the same table that we used for the shortest job first and the SPF. Okay, so let us accommodate first the process A here, process A, and place it in our Gantt chart, and the arrival time is 0, so place it here. So this is the method since we are trying to preempt or detect the incoming processes. Okay, So it will be or possibly be interrupted. Okay, so next is that there will be a new process to arrive. So from the process A, arrival time of 0 here, 0, and the CPU burst here is 8, and it can only process from the CPU burst of 3, because after that 0 arrival time, there will be a process B arriving at 3 milliseconds. Okay, so this CPU burst here will be interrupted, and only 3 milliseconds will be processed from that 8 burst. Okay, so the finished value for process A will just be 3, and process B will now be accommodated. Okay, so let us check. So the next process will be 0, 3, and for letter B here, it will be processed the burst time of 4 for letter B, for the process B. So 4 here plus 3 will give us 7. Okay, so the running or the ongoing time for the processing or the CPU process is now here at 7, here 7 ms, because we are now having a running time, CPU time of 7, so 7. So it will just detect the values, the incoming values or processes up to here, up to this part. So process E is not yet or has not yet arrived. Okay, so though we have a smaller value here, since process E has not yet arrived, it will not be a part of the scheduling. Okay, so the CPU will choose here, will choose from this CPU burst, so which is the smallest. Okay, so from the detection, okay, so this one 8 will be minus by 3, and will give, and we have the remaining waiting value for A, which is 5. Okay, so then we can now check and compare which is the smallest value. Okay, by our checking, this is the smallest burst, CPU burst, and we're going to schedule process D. Okay, so let us continue. Process D will now be accommodated and placed in our queue here. So now process D is now being placed in our queue because CPU burst of 3 is smaller than this one. Okay, or all this CPU burst. Then so 3 now will be added to 7. Okay, so let us add 3 plus 7 will give us 10, of course. So let us continue here, there. So the same that we mentioned, 7 plus 3, which is this one, 7 plus 3 will give us 10. and process D is already executed by the CPU or accommodated. So next, we are now having the total CPU time of 10 here, 10. The total time here is 10. And we can now check from our arrival time or the time scheduling, which is up to here. So we have here arrival time of 10. So this will now be part of the option of the CPU to be scheduled. Okay, so we're done with letter B, which is 4. So this is already processed. So this 8 is already processed and deducted by 3, which is 5, the remaining of 5 bursts. And letter D is already processed, and the option now is this 3 remaining processes, which is the smallest or the shortest remaining time first, comparing these 3 processes, 5, 5, and 2. So the CPU can now identify and detect that process E has the shortest remaining time, and the CPU will schedule and add it here in our Gantt chart. So there will be letter E here. Okay, so let us check. Okay, so we have now letter E here the same way that we mentioned. So from the table of letter E and the CPU burst of 2, 2 will be added to 10. The reason why the total time now is 12. The total process time is 12 milliseconds. Okay, so we're done with this one. We're done with this one. And we're not yet finished with this one. This is deducted by 3 and remaining of 5 CPU bursts. We're already done with process B, and we only have 2 processes to be compared. Okay, so which is smaller, but here we have the same values. So if you have the same values like this, 5 and 5, the CPU will now choose based from the arrival time. So the CPU scheduler will schedule the arrival time of 0, which is from process A. So in our Gantt chart, the CPU will schedule letter A here and will be adding 5 from 12. Okay, so let us check if that's the case. Okay, so we have here process A the same way that we have identified, and the remaining 5 here has been added to 12. So 5 plus 12 will give us 17. The total running time for the scheduling, CPU scheduling, is now 17. Okay, we are not yet done because we're done with this one, we're done with this one, we're done with this one, we're done with process E here, and we only have the last process that has not been allocated to the CPU queue, okay, which is process C. So the last process to be scheduled by the CPU is letter C, and it will get the CPU burst of 5 and will be added to 17. So 15 plus or 5 here, 5 plus 17 will give us 22. So let us check. Okay, so that's the result. So now the CPU scheduler has accommodated process C and added 5 from 17 here, 5 from process C. So 5 plus 17 is 22. Okay, and we're done with our SRTF algorithm scheduling, okay, for all the processes here. So the next thing that we're going to do is to solve for the uh, waiting time, the average waiting time, the turnaround time, and the average turnaround time. So let us continue. So here is the computation. So we solve first for the waiting time of process A, and looking at our last Gantt chart, which is let here A, and our method of looking at the tail first for the waiting time. The tail of letter A is 0, the value is 0, and place it here. And look for the arrival time of letter A, which is 0 and 0. So since in the Gantt chart we could see two processes that has been processed and accommodated, we have here another A. So we're going to continue the process looking at the tail of letter A, 12. That is the tail, and the value is 12, and place it here. And we're going to look at the head of letter A here, head of letter A, and get the value and place it here, which is 3. Okay, so then start subtracting this values, which is 0 and plus 12 minus 3 will give us 9 ms for the waiting time for the process of letter A. So next is for the waiting time of process B. So let us look at the B in our Gantt chart and the tail here of letter B, and get the value of 3 and place it here, and look at the table of process B and get the arrival time of 3 and place it here, and subtract will give us 0 milliseconds. And next is the waiting time for the process C. Look for the process C and its tail and get the value, which is 17, and look at the process C here and get the arrival time of 4 and place it here, then subtract will give us 13 ms, and continue solving the waiting time for the process D, and look for the process D here in our Gantt chart and look at the tail of letter D, get the value of 7 and place it here, and look for the table for process D and get the arrival time of 6 and place it here, then subtract and will give us 1 milliseconds, and continue for the last waiting time for the process E, and look for the process E here in our Gantt chart, the tail part of letter E, and the value of that is 10, and place it here 10, then look at the process E here in our table, then get the arrival time of 10. So place it here. 10 minus 10 will give us 0 ms. Then we can now compute for the average waiting time for this 5 processes. So let us get all the values, which is 9, which is this one, 9, 0, 0, 13, plus 13, plus 1, here, plus 1, plus 0, plus 0. And we're going to divide it again by 5 because we have 5 total processes here in our table. Okay, then adding all these numbers will give us 23, and we're going to divide it by 5 and will give us 4.6 ms. So this is 4.6 ms is our average waiting time for SRTF. Okay, so let us place our table here and continue to solve for the turnaround time for the SRTF. So let us place the last Gantt chart as our guide, and solving for the turnaround time of process A. So we're going to look at the Gantt chart first of our letter A here, which is we have 2 processes of letter A or process A. So by our rules or guide, we look for the head part of our letter A. So we're going to use this, the head of the last process A here, which is 17. We cannot use this process A head, which is 3, because this is not the last head part of our letter A or process A. So we're going to use 17 for our head of process A. So we're going to place it here, 17, and we're going to look at our process A and get the arrival time, 0, and we'll place it here and subtract, will give us 17 ms, and we'll continue to the turnaround process for B, and look for the process B in our Gantt chart and check the head part of B and get the value of 7 and place it here, and look at our table for process B and get the arrival time and place it here, which is 3, and subtract will give us 4 milliseconds, and continue for the turnaround time of process C. Look at the Gantt chart, C, look for the head part of letter C and get the value of 22 and place it here, and look for the table for the process C and get the arrival time of 4 and place it here, and subtract will give us 18 ms, and continue for the process D and look for the Gantt chart for process D and the head part of the process D and get the value of 10 and place it here, and go to the table for process D and get the arrival time of 6 and place it here, then subtract will give us 4 ms. And the last turnaround time for the process E, and look for the Gantt chart of process E and look for the head part of process E and get the 12, the value of 12 here, and go to the process E in our table and get the arrival time of 10 and place it here, and subtract will give us 2 milliseconds. Okay, we can now solve for the average turnaround time of all the processes in our table. So we get 17, place it here. So we add 4 and place it here. We add 18, place it here. We add 4 and place it here. And last, we add 2 and place it here. And we divide it again by 5 because again, we have 5 total processes in our table here. And adding all the given values here will give us 45, and divided by 5 will give us 9 milliseconds for the average turnaround time. So the value for the average turnaround time is 9 milliseconds. So that's it. We're done solving the SRTF, average waiting time, and the average turnaround time. Okay, then later we're going to compare all the algorithm, if which is the fastest among all the 3 that we have solved. Okay, so let us move to our last part, which is we're done. Okay, again, we're going to continue our lesson, and I'm going to show you the result from our computation, and we're going to compare which is the best and fastest algorithm based from our solution and computation. So we're done here. See you in our next lesson. Thank you so much.